Welcome to today's class. In the last class, we learnt about thermometry. That means measuring of temperature. Measuring of temperature by considering two reference points. One is ice point, other one is steam point. Okay, by considering two reference points and governing equation T equal to Ax plus B, and we derive a relation in between centigrade scale and Fahrenheit scale, and we completed some of the problems related to the temperature scales. Okay, now in this class we will see a single reference point temperature scale. Okay, first one, a single reference point for thermometry. That means to measure the temperature, a single reference point. The second one, constant volume and constant pressure thermometers. Right? The third one, ideal gas temperature scale. Scale. Right. These three I will explain in this video. Now, a single point reference point thermometer, what is? In 1954, in the conference of standards, weights and measures, in that instead of considering two reference points, they proposed to consider triple point as the reference point for measurement of temperature, because to obtain the ice point and to obtain the steam point is very difficult in the laboratory level, and the steam point highly sensitive to pressure, and it will vary. Suppose if the atmospheric pressure, a slight difference is there, immediately the steam point will vary. And ice point, the maintaining of equilibrium condition in between ice and the normal water, okay, it is somewhat difficult. Okay, to overcome these difficulties, they proposed triple point as the reference point for measurement of temperature. And the triple point of water, okay, the triple point of water is 273.16 kelvins. 273.16 kelvins. Here, triple point means existence of ice, water and vapor, solid, liquid and vapor. Okay, these three phases coexisted at this point. Okay, and obtaining of this triple point in the laboratory level also, it is very easy. Okay, that is the reason this triple point they consider as the reference point. Now come to thermometer. Suppose if you consider a single reference point, obviously the equation for temperature T at x is equal to A into x. Okay? T E x equal to x, phi equal to mx. Okay? Likewise, right? That means where Tx is the temperature Tx is the temperature at x response of the thermometric property. ఓకే, మనం ఏదైతే థర్మోమెట్రిక్ ప్రాపర్టీ తీసుకున్నామో ఆ థర్మోమెట్రిక్ ప్రాపర్టీ రెస్పాన్స్ దగ్గర ఉన్న టెంపరేచర్ Tx అవుతుంది. X is the thermometric property response. Okay, thermometric property response. This is the X. Now Tx equal to X. Suppose one variable is there, one equation is sufficient, and if you consider triple point, okay, therefore T at triple point I can write TRI, okay, triple point. T at triple point is equal to A into respect to X, okay, response at the triple point. Right? Now for the first equation we can write A equal to Tx by X. Here from this equation we can write A equal to T at triple point divided by X at the triple point. Okay, right. Now this A is same for both the equation. Now equate it. Okay, if we equate this true, then Tx bar X is equal to T at a triple point by X at a triple point. Okay, now our intention is to find the temperature at X instant, right? Therefore Tx is equal to X into T at triple point divided by X at triple point. Right. Further it can be written as temperature at triple point, that is equal to 273.16. 273.16 into X by temperature response at the triple point. Okay. Now see, we can write, right? Suppose you consider 5 types of thermometers. We consider 5 types of thermometers. Okay, those thermometers are constant volume thermometer, constant pressure thermometer, resistance thermometer, thermocouple based thermometer, and mercury thermometer. Okay, these 5 types of thermometers we consider. Suppose if you consider constant volume thermometer, suppose if you consider constant volume thermometer, what is the thermometric property is variable? Volume is constant, then pressure is variable. Okay, therefore pressure is variable or thermometric property. Thermometric property. Pressure is thermometric property. Then Tx is equal to 2.273.16 into pressure at that particular instant P at X by P at what point? Triple point. Okay, that P at triple point. P at triple point. Okay, this will give the respective temperature, right? Suppose if you consider constant pressure bed thermometer, constant pressure thermometer. Okay, in the constant pressure thermometer, volume is thermometric property or volume is variable. Thermometric property. Right. Now the equation will be Tx is equal to 273.16 V at x instant divided by V at triple point. Okay. Suppose if you consider what it called resistance based thermometer. Okay, in the resistance based thermometer, that variable is the resistance. Okay, therefore, in the variable resistance thermometer, variable resistance thermometer, right? In that Tx is equal to 273.16 into resistance of the respective thermometric substance at x instant. Variable resistance thermometer T at x instant is equal to 273.16 into resistance at x instant divided by resistance at the triple point. Okay. Likewise, we can write the equation for the thermocouple based thermometer as well as the mercury thermometer. I will write it. Consider thermocouple based thermometer. Okay, in such cases, the produced EMF, that is the variable. Okay, at particular temperature, the EMF will be different. Okay, therefore Tx equal to 273.16 into EMF. Okay, EMF at x instant divided by EMF produced at the triple point. Okay, right. Next one. If you consider mercury thermometer, in mercury thermometer, length is the variable. Length is variable. Right. Now in such cases, Tx equal to 273.16 into length at x instant divided by length of the mercury column at the triple point. Okay. Likewise, if you consider triple point as the reference point, we can write the equations for the different types of thermometers. After considering these 5 thermometers, one experiment was conducted by the scientists. Okay, a hot bath. That is assume this is the system that is having hot water. This hot water temperature, it is measured by these 5 types of thermometers. First one is constant volume thermometer. The second one is constant pressure thermometer. The third one is variable resistance thermometer, and fourth one is thermocouple thermometer. Fifth one, that is mercury thermometer. Okay, so the same system temperature that was measured by these 5 types of thermometers. Okay, among all the 5 types of thermometers, each thermometer gives a different reading. Okay, some variation. The temperature of the bath, hot bath is same, but each thermometer gives some different reading. Okay, but the variation in the temperature, it is very minimum in the constant pressure gas thermometer and constant volume gas thermometers. Okay, in these among all 5 thermometers, gas thermometers gives a small error. Okay, in that also constant pressure thermometer gives a different value and constant volume thermometer gas thermometer gives a different value, but the difference in between these values are negligible. Okay, that is the reason they concluded that the gas thermometers are more reliable thermometers. The gas thermometers are the more reliable thermometers by considering a triple point as the reference point. Okay, right. Student has to note these points. Gas thermometers are gives the temperature with minute error. Okay, or gives us. Now, before going to give an equation for the measurement of temperature with the gas thermometer, we need to recall some of the basics which we learned in the intermediate level. Right? First one is the universal gas law. Okay, universal gas law. The universal gas law is derived from different experiments. Okay, and first we derived the Boyle's law, after that Charles law, and Charles law at constant pressure, and Charles law at constant volume, Boyle's law at constant temperature we consider, and if we club all these 3 we get an equation P1 V1 by T1 equal to P2 V2 by T2. After that we are introduced a universal gas constant, and the after that the gas equation we can write. The gas equation is P specific volume V into R, here I can write V bar and R bar into T. Okay, V as the V bar is the specific volume. Okay, units specific volume meter cube per kg. Right. Next one, R bar equal to universal gas constant. Universal gas constant. Right? Is the universal gas constant. Its value is 8.314 joule per mole Kelvin. Right. Now, if you take P V bar equal to RT, you can write, where capital R is the characteristic gas constant, right? And this characteristic gas constant we can write it as R equal to R bar by molecular weight mu, right? Next, suppose if you consider total volume, okay, here specific volume, that means meter cube per kg, okay, and if you multiply with mass, then it will give us the total volume. Okay. If the total volume, that means PV bar into mass equal to mass R T. Okay. Therefore, we can write PV. V represents total volume. PV equal to MRT. Okay. This is one equation. This is the one equation. This is by considering universal gas constant. Okay, these equations students need to remember. It can be written as PV M R equal to R bar by mu. R bar by mu into T. Okay, mass by molecular weight. That will give N. That means number of moles. Okay, therefore PV equal to N R bar T. Okay, this is the other equation. These equations, equation 1, 2, 3, 4 and 5. These the students should remember whenever in the problems according to the given parameters. If it is required to use any equation, the student can implement directly there. Okay. Now, why we recall all these things? Here, temperature term it is there. Okay. Right. T is equal to PV by R. T equal to PV by MR. Right? Or if you consider P specific volume, if you consider PV by R. Right? Now, if you can see when it is a constant volume thermometer. If it is a constant volume thermometer, this volume is constant, R is constant. Only variable is the pressure. Okay. Therefore, that variable T at x instant equal to V by R. Okay. Into P at that particular instant. Okay. Similarly, if pressure is constant, then T at x instant equal to P by R into specific volume at that particular instant. Likewise, we can find the temperatures by using this equation. Consider the variation of temperature. If you consider variation of temperature, delta T at x is equal to delta V by R, V by R into delta P at x instant. Nothing plus delta Tx at x instant when pressure is constant, P by R it will be, and the variable is volume by x. Right? Likewise, we can find the respective principles and you can use the thermometers. Now we will see the second one, constant volume and constant pressure thermometers. Okay, and constant volume and constant pressure thermometers, gas thermometers. First, I will consider the constant volume gas thermometer. For that, let us assume this is a bulb. Okay, and it is connected with a capillary tube like this, right? And this capillary tube further it is extended up to here. After that, here onwards, a flexible tube that is connected. This is the flexible tube. Okay, this is flexible tube, and this flexible tube again it is connected with a capillary tube here, and this is exposed to outside atmosphere. Therefore, atmospheric pressure P atmosphere is acted over that. Okay, now this bulb is filled with a gas. Okay, it is filled with gas. It is filled with gas. Okay, and here the mercury filled here to here. Right, this is Hg. Okay, to distinguish only, just I will show the hatching. This is Hg, mercury. Okay, mercury inside. Right. Now we place initially at atmospheric pressure and at surrounding temperature the level. Okay, here level in the right limb and level in the left limb. Okay, this is the right limb, this is the left limb. Okay, level of mercury in the right limb, level of mercury in the left limb, both are equal. Okay, right. And this level and lower level, whichever is the lower level, that we can consider as the reference. Here, this is the reference level. Okay, initial reference level. Now we place this gas thermometer bulb in a system. Okay, before placing the system, what is the volume of gas? The volume filled in the bulb and the gas up to here. This is the volume. Okay, let V is the volume of gas at initial stage. Right? And this is the constant volume gas thermometer. This is constant volume gas thermometer. This is constant volume gas thermometer. Right. Now, a system or a bath, inside the bath, it may be hot bath or cold bath. Okay, it is placed in that. Okay, bulb is placed in that. Now, due to its temperature, what happens? The gas will expand. Okay, and it exerts the pressure over the mercury. Okay, once it is exerted, then the mercury level in the left limb it will raise. Okay, even though it raises, again you need to keep volume as constant or volume at the reference level or level of the Hg in the right limb at this point only. Okay, that shows the volume remains constant. Okay, by adjusting the right limb. Okay, this pike gani kinda gani laga anukonte. Okay, level of mercury in the right limb again it reaches the initial reference point, so that the volume of the gas in the right limb that will be constant. Okay, now after putting this, let us assume the Hg up to this. Okay, and the height of Hg mercury in the left limb, let it be H. Okay, then write the equilibrium equation. Okay, here pressure in the right limb pressure of gas. Okay, ఇటువైపు మనకి ఏంటి యాక్ట్ చేస్తుంది, ప్రెజర్ ఆఫ్ గ్యాస్ యాక్ట్ చేస్తుంది. ఇటువైపు అట్మాస్ఫియరిక్ ప్రెజర్ ప్లస్ దిస్ మెర్క్యూరీ ఈజ్ ఈక్వల్ టు P atmospheric plus pressure due to mercury. Okay, is it right? Is it right? Just you can say check. Pressure of gas ante manaki idi reference kan తీసుకున్నాం. Okay, after existing the pressure exerted by this gas is equal to atmospheric pressure and mercury pressure. Okay, next this can be written as P atmospheric plus PHG rho GH. You can write like this, rho GH, pressure of gas. Now it is PAPM, that means atmospheric pressure plus rho GH. Okay, here rho GH density of the mercury into G, acceleration due to gravity and height of the mercury. Okay, these three terms. Okay, how it gives the pressure, just you can check it. Okay, rho means mass by volume, right? Next G, meter square by acceleration. Okay, I can write G like this, meters per second square, right? Next H, meter, right? F equal to ma. We know that mass into acceleration, that gives us a force, right? Force, and this is meter and v cube, that is in the meter cube, volume cube, meter cube, volume is in the meter cube. Okay, here mass by volume is in the meter cube, right? Now meter square. Okay, then it will give us a force per meter square or force per area. Okay, that will gives us a pressure. Force per area is pressure, right? That means rho GH gives us a pressure in terms of height of mercury, right? This equation also students need to remember. Once you know the pressure, you can put the equation T, gas equation already we derived T equal to PV by R. Okay, here volume remains constant, therefore V by R, initial volume R. Okay, and whatever be the delta P we observe. Okay, that delta P we can write delta T equal to V by R into delta P. Now the same principle we can use for the constant pressure. The same principle we can use for the constant pressure, right? And this is the flexible tube. And this one capillary tube, and again this is filled with mercury, right? Mercury. Here gas, right? And this is the reference pressure. Okay, this is reference pressure, and with respect to volume V. Now P is constant, and that is the reference pressure. Suppose if you put this bulb in a hot bath, due to that gas will expand and it will apply the force over the mercury and mercury level will increase. Okay, now you need to equate these two references again. Okay, now if you equate these two references, volume will change. Initially at this reference pressure, the volume is this reference volume. Okay, this is the reference volume. Okay, this one is the reference. sorry, this is constant pressure, no? Right, constant pressure gas thermometer. Alright, once again I explain. Now we consider gas here and mercury here, and it is exposed to the atmosphere. Now due to the high temperature, the volume of gas will change, okay, and it will compress. Again you need to adjust the what called this flexible pipe, so that pressure we need to be keep constant. Okay, initially some pressure is obtained here, no? The same pressure we need to maintain in here. Then volume will change. Okay, what is the volume? The volume here up to here. Okay, next time that may be here. The next time it may be here. Okay, the volume will change. Okay, the change in volume, if we consider, then temperature Tx equal to change in volume, that is P by R is this constant, and delta V. Okay, that change in volume we need to place here. Delta T at x instant is equal to P by R into delta V. Okay, likewise the gas thermometer, constant volume gas thermometer, gas and pressure thermometer we can use, and we can measure the respective temperatures.